The integral, the indefinite integral. An antiderivative of a function f is a function capital F such that capital F prime of x is equal to f of x. If the derivative of a of x is b of x, then an antiderivative of b of x is a of x. We call the set of all antiderivatives of a function the indefinite integral of that function. The elongated s sign in front of an f of x ending with dx is what we refer to as the indefinite integral of f of x with respect to x. So for example, the indefinite integral of 3x squared dx is x cubed. However, we can also say that the indefinite integral of 3x squared dx is x cubed plus 5. In the first case, the derivative of x cubed is 3x squared. And in the case of x cubed plus 5, the derivative is 3x squared again. But we can also see that the derivative of x cubed minus 10 is 3x squared. And so we have a multitude of different antiderivatives or indefinite integrals for 3x squared. So in general, we say that the integral of 3x squared dx is x cubed plus c, where c is an arbitrary constant. And here's the good news. We can check this calculation by just differentiating. For example, the integral of x dx is x squared over 2 plus a constant. By differentiating x squared over 2 plus c, we get 2x divided by 2 plus 0, which is equal to x. And so we've just verified our answer. We do have some rules. The antiderivative of x to the n is equal to x to the n plus 1 divided by n plus 1 plus a constant. And this is for all n that are different from negative 1. Now, if n equals negative 1, the antiderivative of x to the negative 1 dx is equal to natural log of the absolute value of x plus a constant. The antiderivative or integral of e to the x is equal to e to the x plus a constant. For a base that's different from e, the integral of b to the x is b to the x divided by natural log b plus a constant. The antiderivative of absolute value x dx is equal to x times absolute value of x divided by 2 plus a constant. If we want to find the antiderivative of a sum of two functions, we simply take the antiderivative of the first function and add it to the antiderivative of the second function. If we want to find the antiderivative of a constant multiple of a function, then that's equal to that constant k times the antiderivative of the function. For example, the antiderivative of x to the 55 is equal to x to the 56 divided by 56 plus a constant. The second antiderivative, that of 1 over x dx, we notice here that 1 over x is the same thing as x to the power of negative 1. So this integral is really equal to log absolute value x plus a constant. We've seen that the antiderivative of e to the x is equal to e to the x plus a constant. Similarly, we integrate 2 to the x, we get 2 to the x divided by natural log 2 plus a constant. And the antiderivative of absolute value x is, of course, x times absolute value x divided by 2. If we want to go ahead and combine these rules, we can look to evaluate something a little bit more complicated, like the antiderivative of 9x cubed plus 6x to the negative 1 plus 4 to the x dx. Keeping the sum rule in mind, we can evaluate this by simply evaluating each integrand separately. you can see that we've taken all of the constants that precede any of the functions out front of the integral sign. So the integral of 9x cubed becomes 9 times the integral of x cubed. The integral of 6x to the negative 1 becomes 6 times the integral of x to the negative 1. And the integral of 4 to the x remains the integral of 4 to the x since there is no constant in front. Now the antiderivative of 9x cubed is going to be 9 times x to the 4 over 4. 6 times the integral of x to the negative 1 is going to be 6 times natural log of absolute value x. And the integral of 4 to the x is going to be 4 to the x over log 4. And we go ahead and add the constant at the end. The marginal cost to produce baseball caps at a production level of X caps is 4 minus 0.001 X dollars per cap. And the cost of producing 100 caps is $500. What is the cost function? Here what we're given is the cost per cap. So we're not given the cost function, we're given the marginal cost function. And from there, we need to find the total cost function. Remember, the marginal cost is the derivative of total cost. So we know then that c prime of x is equal to 4 minus 0.001x. And again, we're looking for c of x. We take the antiderivative, we get the antiderivative of 4 minus 0.001x equals 4x minus 0.0005 x squared plus some constant k. Now here we didn't refer to our constant as c because we've already used c a couple of times in this example. We don't want to get confused. We also know something about this constant. We know that 100 caps costs us $500. So if we look at c of 100, that should be equal to 500. So 500, which is equal to c of 100, is equal to 4 times 100 minus 0.0005 times 100 squared plus k. And if we solve that for k is equal to 105. And so our cost function, at the end of the day, is going to be 4x minus 0.0005 x squared plus 105.